You don't have to know this one. The one down here is the one you look at. So this formula, the binomial theorem. All right, binomial theorem is what I just said, right? So your coefficients are just n choose 0, n choose 1, n choose 2, okay, for when it's to the nth power, okay? And then your a's and b's are just like we did yesterday. So the first a is n minus 1, n minus 2, it just goes down, and then the b's start at 0 and go up. So that's all the same. All right, so now they want us to expand this one using binomial theorem instead of using Pascal's triangle, just to practice it. Now, a problem like this, when it's only to the 4th power, I would just say do Pascal's triangle, right? But let's just show how it works with binomial theorem, okay? So for binomial theorem, that means that the first coefficient would be 4, because that's my n, choose 0, a to the 4th, plus 4, choose 1, a to the 3rd, b to the 1st. Plus, and I'm just following this pattern up here, right? And I'm using n as 4. 4, choose 2, a squared, b squared. Plus 4, choose 3, a b to the 3rd, plus 4, choose 4, b to the 4th. Okay? And then you go to your calculator and be like, okay, what is 4, choose 0? Right? Yeah, we know it's going to be 1, but just in case we didn't know it, we would go here and type 4, choose 0, and we'd get 1. So this would just be a to the 4th. And then we'd do 4. So you see why like Pascal is going to be a little quicker here? 4, a to the 3rd, b. And then I do 4, whoops, choose 2, and I get a 6. And this is corresponding, right, to Pascal's triangle. 4. What's going on, kids?
Why are you shutting this up? What? I'm making a comment that Pascal is the name of the chameleon entangled.
I said that.
Oh, I said
yesterday.
Oh, it is.
This is true.
It says that. I'm like, oh, chameleon. Oh, chameleon.
I think Katie's the problem here. We should probably send her.
I know, I think she should leave. All right, so your coefficients, as you notice, are 1, 4, 6, 4, 1, right? And that's what we got. Oh, look, Pascal's triangle, 1, 4, 6, 4, 1. Okay, so you can either use the binomial theorem to get your coefficients, or you could use the other one. I'm not going to walk us through the next one. I think you guys get the idea. Are we good? Can I skip that example? Okay. What I want you to notice now, though, so why is this important? Why should we use binomial theorem? Again, it's really going to be for when we have larger expansions, like to the 18th power, to the 15th power, okay? And usually what you're going to want when we have those larger expansions, I'm not going to ask you to expand the whole thing out. I mean, that would take an entire sheet of paper to expand something to the 18th power, okay? I don't want you to do that. But what I am going to ask you are certain things like find the 15th term when it's expanded out to 18 terms, okay? What's the 15th term? Or what's the 22nd term when it's expanded out to 29 terms or something like that, okay? So you're going to have to find a specific term. So what they've come up with is this formula, and this is the one you do need to memorize, okay, is that the coefficient of the rth term, so again, like I'm asking you for the 15th term, that would be the rth term. I sound like I'm barking. The rth term. My poor son would not be able to say that. He'd be like, oh, oh. He can't do his R's yet. He's working on it. Rth term, okay, is n choose r minus 1, always. So what did you notice here, right? N choose r minus 1. That's the term number. This is the first term, so it's 0. This is the second term, so it's 1. This is the third term, so it's 2. So that bottom number is always r minus 1, the position of the term minus 1, okay? All right, that's the first thing to know. The exponent for a, if you notice, is always n minus that number on the bottom. Okay, so look at your exponents for a here, right? Exponents for a. So this one is 4, okay? And 4, it was 4. Oh, look, it's just the difference of these two. 4 minus 0 gives me 4. And look here, 4 minus 1 gives me 3. And 4 minus 2 gives me 2. So the exponent of your a is the difference of your n and your k up in that coefficient, okay? So that'll work every single time. So you take the difference of those two, and it'll give you the exponent for your a. What about the exponent for your b? How did we get the exponent for the b? It's the same as the bottom number. You're exactly right. Okay, the exponent for your b is always the same as the bottom number. Exponent for a is always the difference of the two. Okay, so putting all that information together, they came up with this nice little formula. Okay, and on the top, r minus 1 on the bottom. Remember, r again is the position of that term. So is it term number 1, term number 2, term number 3? That's what r means. Okay, so n over r minus 1. And notice, remember we said a, the exponent of a, is just the difference of these two numbers, n minus the bottom one. And the exponent for b is just that bottom number. This you need to memorize.
Is it multiplying to the power of?
A is to the power of, and then times b to the power of. Those are all powers of.
Okay.
Those are the exponents. All right, so let's do example 4, and we'll figure it out. So here, when it says find the 15th term, 15 is r. Okay? That's the term number I want, the place of that term. In the expansion of x squared minus 1 over x to the 18th. So 18 is my n. Okay. My a term is x squared. And my b term is 1 over x. Now you could rewrite this as x to the negative 1, or you could leave it as 1 over x, whatever you prefer. At the end, I would prefer all your exponents to be positive. So if you switch it negative, I would like you to return it to be positive at the end. But I would leave it like that for now. Okay, oh, and in these ones, wait a second, I made a mistake. You have to include that negative in these ones because, like the 15th term, I'll be like, wait, I have to start at the first one, and then I have to do positive, negative, positive, negative, positive, negative, and then is 15th going to be positive, or is it going to be negative? I don't know, right? So the easier way to do it is just include that negative with your b term. Okay? You could count. I would mess it up, but you can count it.
Isn't odds always end in negative and evens always end in
No, it depends how many, well, of the term. You mean r, like the r one? So the 15th one would be negative? Yeah, because you'd always start positive.
Well, is it one?
No, it would be positive. Positives would be even numbers, would be negatives.
One positive, two negative.
I think that's true, but I would double check it. But I think that might be true.
Yeah, I think so.
Okay, so let's try it with the negative in there. Here's the formula we want to use. N choose r minus 1. So I fill this in. N is 18. R minus 1 would be 15 minus 1, so it would be 14. Okay. A, I just put in x squared. The exponent for a, and for me, instead of using this formula, it's actually easier just to do top minus bottom, because that's really all it is. So it's the top number minus the bottom number, always. If you got these two right, you're good. So do top minus bottom, so it would just be 18 minus 14. And then my b term, again, I'm going to include that negative for now, but I think your theory will work. So then this would be to the r minus 1. The other way I like to do that is just say it's to the bottom number. So it's just always to whatever that bottom number is. And then again, this is just top minus bottom. All right, so 18 choose 14. Again, you can do that on your calculator. And you get 3060. X squared raised to the 4th, power to a power, then you multiply. And then this guy, negative 1 over x to the 14th, would just be positive 1 over x to the 14th. Okay, and then I got to simplify this, so sorry, I need more room. 3060, I've got x to the 8th over x to the 14th. So that simplifies to x to the 6th down there. And I think that looks correct. Let me double check that I didn't make a mistake. Yeah, that works. If you rewrote it, I guess I don't know if we'd take negatives, but either one's fine. I would say or. You could do either or. Okay? So, again, using the formula is going to be a lot quicker than trying to expand something out 18 times. All right, now this one's a little different. This one wants you to find the coefficient, so a little working backwards here, of the term containing an x to the 6th. in this expansion. Okay? So they want to figure out which term it is, and then so we don't know what r is. I don't know if r is equal to, I don't know what r is, right? So what I have to figure out here is I'm going to work backwards. I'm going to take this a term because that's the one that has an x in it. Okay? So I know it's got to be something with the a term. I don't really care about the b term here. So that a term is 2x to the second. So what power does that term need to be raised to in order to get an x to the sixth term?
Third.
It needs to be raised to the third power, right? So this exponent needs to be a 3. So the exponent of my a term needs to be a 3. Well, go back. What was our formula? Our formula was that a to the n minus r minus 1. So n minus r minus 1 has to equal 3. Okay, because this, our formula told us, the formula for the exponent, it was n minus r minus 1, right? That exponent has to equal 3 in order to get an x to the sixth term. Okay, so then I just set this equation, but what do I know here? Do I know n or do I know r? I know n is 30. So now I can do 3 equals 30 minus r minus 1. And I'm trying to figure out what r is. That's my whole point of this. Okay. So I distribute my negatives. And I keep going here. I get 3 equals 31 minus r. So r equals 34. No, 28.
28.
That's what I thought. Oh, you almost caught me.
I thought I could.
R equals 28. Okay. Now we're still not done because we have to find the coefficient of that 28th term now. So now we're kind of back to this problem. Okay. Finding the 28th term. Now I actually didn't want the whole thing. This one just asked for the coefficient. So you got to be careful. Sometimes I'll ask you for the whole term. Other times I just want the coefficient of the term. In this case, I just want the coefficient of that term. Okay. So let's go through the formula here. R is 28, N was 30. So then here 28 minus 1 would be 27. Again, my A term is 2x squared. And then we know it's the difference of these two, top minus bottom, so it's 3. And then my B term is y squared, and that's going to be raised to the bottom one, which is 27. All right, what's 30? Choose 27. 40, 60. Interesting. 2 to the third is 8. X to the 6th. Y to the 54th. And we only need the coefficient, so I'm still not there yet, though, because I have to multiply 40, 60 times 8 to get my official coefficient. 32, 480. If I wanted the whole term, I would do all of this, but it just asked for coefficient only. Okay. Coefficient only. You said one more to do. You can go. You got the gist of it.
Okay.
Okay, go. Good luck.
Thank you.
All right, so another thing, though, I do like to do is I actually like to work out the whole term just to check that I make sure that I did have, indeed, the one that it asked for. It asked for the one containing x to the 6th. And, okay, it does have an x to the 6th, so I'm good. All right. This next one's very similar, but it's a little more confusing because I have an a term and a b term that both have a's in them. This first part was kind of easy because I only had to worry about a affecting that exponent, right? Because the other one was a y, so it didn't matter. Okay. But this one, it does make a difference because they're both going to have a combined, like this will get combined with this one. Okay. So how do we work this one out? And let's start it off. We want the coefficient of the term containing a to the 9th. So what I'm going to do is I'm actually going to start with the whole formula from the top. So my whole formula is n in this case is 10. Okay, so it's 10. Choose r minus 1. I don't know what r minus 1 is yet because I don't know what r is. Okay. And then my a term in this case is a. Isn't that nice? To the top minus bottom. So 10 minus the quantity, r minus 1, careful with parentheses and negatives. And then my b term is this whole thing. Can I rewrite that? Yeah, 2a to the 1/2. I'm going to rewrite it like that. Sorry. Did I hear you? So you have a question? Yes. Go.
Would it be 10 or 11 minus r? Because
It will be 11 minus r. Yes, we're going to go there in a sec. You're exactly right. You're a step ahead of me. So I'm going to simplify this. This would be 2 to the 1/2, a to the 1/2. Okay? So then it's my b term. And that whole b term is raised to the bottom number, which is r minus 1. Let's keep going here. So this is 10 over r minus 1. And then you're right, this would just become, because you distribute your negative, so it would be 11 minus r. And then here this r minus 1 distributes into both. So I have a 2 to the 1/2 r minus 1/2. And then a to the 1/2 r minus 1/2. Okay. What am I concerned about? I'm concerned about the a's, right? I want the a's to equal a to the 9th. So I basically want to take these a's, that one and this one, okay? Because that's what I really want to know about here. That's a to the 11 minus r and a to the 1/2 r minus 1/2. And I want that to equal a to the 9th. So I need to get an equation here, and when you multiply, you add. When you multiply, you add, right? So I want to add these two exponents on the left, and they should equal 9. And then I can solve for r, and everything's great because I figure out what my r is. So I want to add these two, 11 minus r plus 1/2 r minus 1/2, and I want that to equal that exponent on the right. Combine like terms, 11 minus 1/2, so I've got 10.5, negative r plus 1/2, so negative 0.5 r. Okay, subtract, solve, what do we get? Negative 3? How did I get negative 3? Positive 3. Thank you. I forgot a negative. I'm like, r can't be negative, so. Yes.
How
Yeah.
did you get a equals a to the 9th?
Here?
Right there, yeah.
Because they told us in the problem that they wanted the term with an a to the 9th.
oh, that's not
Okay.
the answer.
That's not the answer.
Oh, right.
So what we've gotten so far is we've gotten what term it is. Okay, so now we figured out the r, and now we're basically back to problem A, which said now find the problem, right, with the third term. Okay, so now what I need to do, now that I know that r is equal to 3, I can kind of go back in here, right, and plug in 3's. And again, it's only asking for the coefficient. So now what I really can do is ignore the a stuff. I don't really care about the a stuff. And I can just take this and this, which are the things without the a's, plug in a 3 for both of them, multiply them out, and then you get your answer, right? Because that'll give me the coefficients. So I'm going to take this r equals 3, and I'm going to plug it in here. I'm going to plug it in here. I know that these other two together equal the 9, so I don't really have to worry about them anymore. Okay, so I'm going to plug in here. That means I have 10 choose 2 times 2 to the 1/2 of 3 minus 1/2. All right, what's 10 choose 2? How much? Someone do it yet? The final answer? 10 choose 2 is 45.
Oh.
That part, right? And then here, 1/2 of 3 is 3/2 minus 1/2, so that's just 1. So it's just 90. And that's my coefficient.
That's a lot of work.
That was a lot of brain power for a Friday morning. Hey, at least it stopped snowing, you guys. Okay, I want us to practice just a couple before the bell rings here. So go ahead to your practice packet. And let's just try that first one.
Pretty sure.
Yellow practice packet, you with me? Let's try number 1. I guess I could stop my notes here.
I got it.